Antidifferentiation and Baseball. Okay. We were talking about baseballs in my last video, and it's now time to continue my discussion on baseballs. Okay. Now, in my last video, I was telling you that you could have a negative acceleration and a negative velocity. Acceleration and velocity can be negative or positive. It's only speed that has to be positive. Okay. Now we're going to start this equation with a negative acceleration of 32 feet per second squared. If you'll remember, I was talking about Galileo, and Galileo said that any object dropping near the Earth's surface will drop at negative 32 feet per second squared. So, we've got a negative acceleration of 32 feet per second squared. That means we have a derived velocity equation of negative 32 times t to the 0. Now, if you'll remember, t to the 0 is 0, so, well, actually, whether it be 0 or 1, it doesn't make any difference what it is. The point is that you end up with negative 32, and that's all. Alright? So anyway, you now have a velocity of negative 32 times t to the 1 plus c. Now we have a constant, because we're going to say that we started with initial velocity when we threw the baseball of 196 feet per second. Okay? That's right, we're going to start with a velocity of 196 feet per second. Wow! So, 196 equals negative 32 to the, times 0 to the first power plus c. The negative 32 kind of gets eliminated here because negative 32 times 0, no matter how you figure it out, it's going to be like this, plus c. And I am going to post a video about this because I want to make sure I get this exactly right. I may not have gotten it right in my last video. I'm not going to tell you I got it right on this one. So I'm going to cover exponents which have 0 and 1 in my next video to make sure we get this all straightened out. It's been a long time since I've dealt with this, but I can assure you that this 0 to the first power and 0 to the 0 power is going to be all canceled out, and you'll still have your negative 32, and I'll cover that in my next video. I should have covered that a long time ago, and I will do so. Alright, so you have 196. Negative 32 is times 0, so that makes it 0 plus c, which makes 196 equals c. So therefore, your velocity is negative 32t to the first power plus 196. Now, of course, this is a derived equation. Alright, so we're going to once again use spatium. Okay? Because spatium is going to represent distance for part of this equation, and the other part is going to represent height. Okay? So we can't always say it's going to be total height, because it's going to start off with a distance, then it's going to turn to height. And I'll show you that in just a second here. Alright. We have a derived equation of a negative 32t plus 196. We're going to anti-derive this equation, and when we do, we get negative 16t squared plus 196t plus c. How did we get that? Alright. This piece right here, we had t to the first power. We added 1 to that t, so t to the first power plus 1 is t to the second power. Okay, so now instead of having t to the first power, we have t squared, and then we divided the negative 32 by that 2. And therefore we got negative 16t squared. Now, how do we get the 196t? Well, we had 196 times t to the 0 power. Now we have 196 times t to the 1 power. Okay, so t to the 0 plus 1 is t to the 1. Okay, now we have a constant here. Alright, now when we go through this later, we're going to find out we don't have a constant, but we're going to assume that we do. Okay, So we're going to assume that there was a certain amount of distance already traveled before we started this equation. Of course, we're going to figure out in about 10 seconds that that wasn't the case. But it could have been. Alright, so we have spatium equaling negative 16t squared plus 196t plus c. Alright, we're going to say that no distance, that the ball did not go anywhere up off the ground the very second that ball started traveling. Okay, so it has not achieved any distance yet. It's already achieved a velocity, but it has never achieved any distance yet. Okay, so spatium is 0, so therefore no time has elapsed, which zeroes this out here, and of course we're taking 196 times 0 because remember, the ball when it initially goes up, it's traveling at 196 feet per second, but it hasn't gone up anywhere yet. So 196 times 0, there you go, and we have c. Now later on, we'll show you how to make that c a reality. So anyway, c is 0, so there is no constant here, so we have an equation. Spatium equals 196t minus 16t squared. Okay, let's plug in some numbers and see what happens. Alright, if we take 196 times 1 and we take 16 times 1, we're going to, of course, get 196 and 16 respectively. So you're going to have an equation that's going to say S equals 190, whoops, let me write this down correctly. 196 minus 16. And if you take 196 minus 16, you get 180. Okay. Now then, let's go up to 2 seconds. Okay, so 196 times 2 is 392. And 16 times 2 is 32. So 392 minus 32 gives you 360. And we could go on and on and on about this. Now, at a certain point, this equation is going to indicate to you that the ball has reached a certain height. When you throw a ball up into the air, it's going to go a certain height, then it's going to start coming back down. And so then, the spatium no longer equals the distance the ball has gone up, but rather the distance that is starting to come down. And eventually, it'll go down to nothing. Alright? And that's what this will, and you can do all the equations yourself. You can actually do all this arithmetic yourself, and you're going to see that the ball will eventually reach a certain height, and then it'll start dropping down. And if you want to post that right here in this wonderful video, leave a comment below, leave a video response below, show me the equation, and boom, I will let it be on there. But you're going to see, and I'll show you this in the end, you have a ball, it goes up in the air, and then it comes back down. Ball starts here, achieves a maximum height, and then it goes back down here. Just like that. Alright, and this equation works for every possible second that it travels. The more seconds that pass by, the more it goes up until it reaches a certain height, then it comes back down. And you'll see this when you chart it for yourself. Alright, I will tell you more in a future video. I may go ahead and show you the exact calculation on that at some future point. You have yourselves a wonderful evening, and I will tell you more in my next video, so stay tuned.